everyone, Ryan here with Boolean Development to show you how to shift arrays in Java. Before we get into the code, let's just talk about the problem first. Shifting arrays is a very important skill to possess in Java programming and something very likely to come up in coding interviews. What I mean by shifting arrays is taking the contents within an array and moving each item in one direction a given number of spaces. Let's take a look at some examples to understand this visually. So given the task to shift an array of 4 numbers by 2 spots to the right, let's visually represent that before we get working on any code. We would need to move the 4 in position sub 3 around to the front, so I'll just pull it down for a second. Then we would need to move the other numbers up 1 spot so that the 3 is now the last number. 4 goes in front, and you've completed one whole rotation. We need to repeat this one more time, and then we will have shifted every number 2 spots to the right. Now let's look at the same example, going to the left this time. We need to do the exact same operation, but shift the numbers the opposite direction. So the 1 will come down this time. We will shift the other 3 numbers to the left, so that the 2 is the first number. 1 goes around to the last position, and we have completed one rotation. Just as last time, we repeat a second iteration of this operation, and we have shifted all the numbers to the left by 2 places. This is the process we are going to make happen in code now. Alright, so I want to show you the program we've got going here in IntelliJ. I want to show you that we are just going to have one main class. We're going to have a main method here. And we're just using this so that we can put some arrays in here of differing lengths and then pass those into method calls so that we can test what we write and make sure that it works. Down here we'll have our 2 methods, right shift and left shift. I've commented left shift out so that we can solve this, figure this out, and then once this one's up and running, we can jump down to left shift, uncomment this, get the whole thing running, and then we'll be able to see our output down below. So this is the boilerplate code. You'll see it all fits on the screen here. If you would like to pause the video and catch up, do so. I strongly encourage you to type all this out because, especially if you're just getting started, Java is a very verbose language, meaning there's a lot of different keywords. There's a lot of different syntax that has to be typed out in a specific way. It's a great opportunity for you to get some muscle memory and just start to kind of get your feet wet as far as typing out Java and just getting into the flow of making programs. Okay? So don't rob yourself of that opportunity. Go get that muscle memory. So let's take a look at this. As we get started, there's 2 concepts that you're going to have to be at least familiar with to understand how this problem works. The first is going to be that arrays are 0 indexed, meaning that they start at the place 0 and they work up. So this 8, because this array starts at place 0, this will actually be position sub 7, even though it's the number 8. So if you're not familiar with that concept of 0 indexing, I'll link the video that I have on that here, and you can go check that out. You can just pause, go catch up, come back, and then you'll fully understand it. And then the other concept is going to be the modulus operator, which is going to give us the quotient after, it's going to give us the remainder after we divide and not the quotient. If that's not a concept you're familiar with, I'll link the video I have for that here, and you can pause and go check that out. Basically, we're going to do division. We're going to get the remainder instead of just solving it like a normal division problem. Okay. So let's jump in. Let's get started and see what this looks like. So we're going to start with our first to do here. And if we just take a look at this method, we're getting an array in here. We're going to get a certain number of shifts that we want to go to the right. And then we're going to move all the numbers that many places. Okay. So I'm using a temp array here, and the reason that I'm doing that is because I don't want to mess with the data that's coming into my method. I want to use it to perform a computation, give a new value out, print a new value out, but I don't want to mess with anything that's actually up here, okay? It's just a good, not that we would even try to solve that problem this way or do anything like that, but we just want to get in the habit of writing pure methods because a lot of times that's the right path to go down, right? So down here, we're going to iterate through it, just starting at the 0th position, and then we're going to move to the end of the array, and we're just going to iterate one number by one number. And if you think about it, all we're really telling these numbers to do is we're going to have this variable, and it's going to be an integer, because we want to give each number that we select a new place, right? So we want to give it a new position, okay? And what we're effectively telling it to do is take this 0, like I want to work with the thing here in the 0th place, which would be 1, and I want to move it however many shifts you told me, right? However many shifts were in the method, passed in here as a parameter, that's what I want to do. And you may think, yeah, that works. That's easy. We just move it this way. That's going to work until we get to these numbers here at the end, in which case we're going to get an out of bounds exception. Because if you take this and you were to say, okay, position 7, right? Go ahead and give me that, add 3 to it. Well, it's going to reach out and go, you're telling me to grab like a position 10 out here, and that doesn't exist. So we're going to get an out of bound exception. It wouldn't even solve the problem the right way that we want to, because we actually want to wrap this back around, right? So what we're going to make use of here is the modulus operator, and we're actually going to divide by the length of the array, right? So what that's going to do, if we just stop and kind of look at our numbers for a second, we're going to be taking the position. So let's look at 8 at this point. If you wrote out a table and you basically iterated through and worked out how many loops this is going to go through, right? Then you're going to get to 7 iterations of this. It'll technically be 8, but you'll stop on the number 7. So you'll have 8 iterations of this, right? So we're going to go through and we're going to go 1, 2, 3, 4, 5, 6, 7, 8 spots, right? And so if I work that out on my table and I say, okay, by the time I'm through with this problem, I'll have iterated through 8 different numbers, okay? So then this number right here is going to be 8, right? I'm sorry, this number is going to be 7 because of this position right here. We're going to be looking at this, and it's going to pass in 7, right? Then we're going to say, give me 3 shifts, which we got from right here, okay? So stick with me. 7th position, we're adding 3 shifts to it. So this number right here would be 10, right? If you just did this, this would be 10. And that's what we were saying a second ago. You would reach all the way out here, and you would have a 10th position. So instead what we do is we say, give me the length of the array, which if you counted it, 1, 2, 3, 4, 5, 6, 7, 8, it's 8 spots, right? It's going to divide this number by 8. So if you took 10 and you divide by 8, you don't need to solve it out as a decimal. Modulus doesn't do that. It just gives the remainder back in the whole number. So if you say, okay, well, 10 divided by 8, 8 goes into it one time and there's 2 left over. So then what it's going to do is once all this solves out, it's just going to give you that remainder because you're saying do this, divide it, and give me the remainder. So this math problem here becomes the number 2. Well, that makes all the sense in the world because what I want 8 to do if it moves 3 spots is go to the 0th position, go to the 1 position, and then go to sub 2 of the array, right? And so that would put it in its correct position. So then all I have to do now is tell it in temp, go to whatever new position comes out to be. Each time this iterates, whatever this comes out to be, and set that as the value of whatever is in I. So right here, if you work back through what we were just saying, take the value that's in position 7, this came out to 2, put it in position 2, right? And it's just going to work through each one of these numbers and do that all the way to the end, wrapping them all back around, and then you solve your problem. So if we were successful, if this is what we were actually supposed to do, we should run this and see our result. So let's see what we get here. So we run it, and just like we said, 8 should go here, here, and here, 3 spots. Let's check 1. 1 should have went 1, 2, and 3. It did. It went from here, 1, 2, and 3. And we see that all the numbers rolled. Let's look at our second example. We told this one to shift 4. So let's take a look at the 5. The 5 should have went to the first, second, third, boom, right there, right? If we check 1, 1 should have went here, 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 and it did, right? So that's how you do the right shift. You may look at all this and go, oh, this is kind of a complex problem. Not really. The bulk of your solution is right here in just like 4 or 5 lines of code, right? This is the bulk of what we're doing here. This is the actual algorithm that we're using to get through this problem. All the rest of this is just a setup for us to check it, all of this stuff. So this is the meat of this problem, and that's what I want you to focus in on, and that's what I want you to study and work through. I always encourage my students to get a piece of paper and work these things out. because you will see it, and once you see it, you'll know it for the rest of your life, okay? So let's go ahead and do the same thing. Let's uncomment our left shift method. Let's go ahead and uncomment our left shift calls. We'll hop down here and look at this. And our second to do, we're doing the exact same operation, but you'll notice here, instead of going to the right, just iterating through, we're actually going to start from the end of the array, right? We want to start from here and work to the left since we're shifting everything to the left. So let's follow that same exact train of thought where we're going to give a new position. We're going to say, integer new position. Just a couple things to note here. We're working from the end of the array, right? So we need to have the same thought process of going to the left this time. And so instead of just adding the shifts, we're actually going to do subtraction using the length of the array. So instead of adding and then dividing by the length of the array, you're going to see we're still going to use modulus here to do the same wrapping to come back in, right, on the array itself. But we're going to start working to the left, so we're going to use subtraction. So what we're going to do, I'm going to wrap this in parentheses. We're going to do I just the same, all right? And we are going to do addition, if I can type here. We're going to do addition with that I, but we're going to take the length of the array this time, and we're going to subtract the left shifts, okay? So let's just, before we get all this kind of worked out and parsed out and finished, let's kind of look at what we've got so far. So we're essentially saying start at the end of the array, work all the way back to the 0th position of the array. So take I, right, which is going to be steadily counting down, right? And then take the length of the array, which will be 8 in this case and 5 in this case, and then subtract the number of shifts you want. And so if you think about that, if you took, the number 8 here and you say, okay, we want to go 4 shifts, you would be doing 8 minus 4, which is going to be 4. And because we're starting here and this is going to be the 0th position, you would be at 4. So it would say move it 1, 2, 3, and 4, right? And then you would be there. Okay, you would move 4 spots over. Again, same exact problem. That works just fine until you get down here to these numbers. 1 can't move 4 spaces. It needs the help of that modulus operator to create the division to come back in and give it a new position on the other side. So what we do here this time is actually the exact same thing we did here. We're just going to do modulus by the length of the array because that gives us the effect of doing the division, giving us the remainder, which will give us the right spot to place our stuff. So let's look back at this example. If you wrote this out, if you wrote your for loop here out in a table and you were to just analyze it and go through and see, okay, where am I at when I start this operation? Here you would start with 0, and we said, you'd move back 4 spots. So let's take a look at one of these that would be a little bit trickier. Just like with this exact same situation we had up here, this will end up being place sub 7, but it's the 8th element in the array, right? So if you take this and you say, okay, this is going to be 8, right? And then I'm going to add to it the length of the array, which is going to be 8. So we solve this first, right? A little PEMDAS for you. Let's look at this part first. Let's take 8 and subtract 4. We get 4. So we're going to add 4 to 8 and we're going to get 12. So this whole thing right here is going to work itself out and it's going to be 12. Okay, makes sense? And then what we're doing is we're taking this and we're saying, go ahead and do division by the length of the array. So if we took 12 and you do 8 and you divide it, 8 goes into 12 once with what left over? 4, right? So what will happen is this will now get the position of 4, right? So if you go, okay, it should go here, 1, 2, 3, and 4. If you were actually to walk through these in the positions, you'd have 0, 1, 2, 3, and right there we've got 4. So notice how it gives it its new position. And this is just an awesome trick. It's a great way to visualize how division works in the first place and how you can use something this simple to really rewrap this. This is what's doing the heavy lifting here, right? Just like I said with this one, this is the bulk of the problem that we're solving. It's the same here, but this is our powerhouse. This is a really cool operation that I love. And it's just something that I love this problem because now it helped me visualize math that sometimes I couldn't see when I was in school. That computer science really helped me. I learned way more math learning computer science than I ever did in school. Just because I got to see it work and I got to kind of play around with these things and build programs. So right here, we see this should, if it all works out, wrap back around. We're not finished just yet. We do have to set temps numbers to the correct position. So we say the new position of temp set to the value in array sub I, and then that should help work that out. If we did this right, we should be able to run these left shifts and see, just like we did with the other ones, the problem solved. So let's take a look at it. Let's check our work. So if I go up here to the top, it should be my second one, right? Because our first one's right, then we go left, then we go right, then we go left. So we should be looking at 2 and 4. So 2, we told it to go, this one right here, we told it to go 3 spots, right? So if I'm doing this correctly, 8 should go 1, 2, and 3. And I see right here it did. It went 1, 2, and 3. 1, right, should have wrapped around, and it should go 1, 2, and 3. I see 1, and it went 1, 2, and 3 spots right there. So that worked. Let's check this one. We told it to move by 4. So this 5 should go 1, 2, 3, 4, and be in the first position. It is. 1 should have wrapped and went 1, 2, 3, and 4, and it should be the second number, and it is. So we see that we've solved these. You can feel free to go through here and plug different things in and check it and just see how it works. I encourage you to kind of take some time to just look at this and maybe get out a piece of paper. I always encourage my students to get out a piece of paper and just visualize this, write it out. I'm going to do some courses in the near future on what it looks like to visualize some concepts in computer science. Because seeing it in your brain, once you see it, you've got it. And then you're able to solve more and more complex problems and understand the world around you and become a fantastic programmer. So if you liked this video, I would love for you to go ahead and subscribe to the channel, like the video, and that helps me out to keep building content, to keep growing my channel, and to put more stuff out there for you. Again, this is Ryan with Bolin Development. I thank you so much for sticking around. You guys are why I do this, and I'm excited to help you learn all this stuff. So, thank you.